Dear students, last lecture में हमने डिस्कस किया what is a binary operation, and in today's lecture we are going to discuss commutative and associative binary operations. First of all, we will discuss commutative binary operation. इस डेफिनेशन को अच्छी तरह समझने के लिए पहले हम कुछ एग्जाम्पल्स देखते हैं. In last lecture we already discussed that addition, usual addition, subtraction are both binary operations on the set Z of integers. So they are both binary operations. Now, in today's lecture, we are going to discuss a property which is enjoyed by addition but not by subtraction. And what is the property? Let us discuss. If we take two integers, say we take 7, we take 5, we add them. So first of all, we will discuss addition. Under addition, what property is enjoyed by addition and which is not enjoyed by subtraction. If we select 7, we select 5, we add them, we get 12. Now if you change the order of the elements in this operation, we write first 5, then 7. पहले हमने 7 लिखा, उसके बाद 5 लिखा. Now let us write first 5 and then 7. What will be the answer? 5 plus 7 is still 12. And 12 is also an integer. Now it means that 7 plus 5 is equal to 5 plus 7. Is it clear? कि अगर हम ऐड करेंगे 7 और 5 में, order is not important. Whether you are adding 7 and 5 or 5 and 7, the answer is same. आपको क्या लगता है? If you take any other pair, say you select 9, you select 5, 9 plus 5 is 14. Change the order, 5 plus 9 is 14. So 9 plus 5 is equal to 5 plus 9. Similarly, if you select any other pair, say you select 3, you select minus 4, you add them because both are integers. You add them 3 plus minus 4, you get minus 1. Now change the order of the elements. Minus 4 plus 3. पहले हमने अब minus 4 लिखा, उसके बाद 3 लिखा. And the answer is still minus 1. It means that 3 plus minus 4 is equal to minus 4 plus 3. So here also the order is not important. Whether you write 3 plus minus 4 or minus 4 plus 3, the answer is same. Now it is in general true that if A and B are any two integers, you add them in any order, whether A plus B or B plus A, the answer will always be same. So I think it is now clear that A plus B is equal to B plus A for all A and B in Z. So what we have discussed, that addition is already a binary operation. But the question is here, the order is not important. Whether we write A plus B or B plus A, the answer is always same. Now let us see the next binary operation, that is subtraction. Here it is plus and now we select minus, subtraction. Now select the same pair of elements which we have selected here, 7 and 5. And see what happened under the subtraction. Because here addition is operation, so we add them. But now we are discussing subtraction, and so we subtract them. And what is 7 minus 5? It is 2. Now change the order of the elements. It is 7 minus 5. You are subtracting 5 from 7. Now let us change the order. Write 5 minus 7. Elements are same. We are simply changing the order of the elements. जिस तरह हमने यहाँ पे change किया, 7 plus 5 and 5 plus 7. यहाँ पे भी वही हम करने जा रहे हैं. So what is 5 minus 7? It is minus 2. Now see the difference. Under addition, 7 plus 5 is 5 plus 7. But under subtraction, 7 plus minus 5 is 2 and 5 minus 7 is minus 2. It means that 7 minus 5 is not equal to 5 minus 7. So see the difference? Both addition and subtraction, they are binary operations on the set Z of integers. But see the additional property which is enjoyed by addition but not by subtraction. Under addition, order is immaterial. Whether you write A plus B or B plus A, no matter. the answer will be same. See the difference? If it is 7 minus 5, you cannot write it 5 minus 7. Because 7 minus 5 is 2 and 5 minus 7 is minus 2. So in general, we can say that this is one particular example. Similarly, if you select any other pair, say you select 5, you select 8, 5 minus 8 is minus 3. Change the order of the elements. 8 minus 5 is 3. So it means 5 minus 8 is not equal to 8 minus 5. It means that in general it is true that A minus B is not equal to B minus A. So this is the difference. Even both are binary operations on the set Z of integers. But see the property. Here it enjoys the property. Here order is immaterial, but here order is important. 7 minus 5 has one value and 5 minus 7 has another value. So order is important here, but order is not important here. And this property motivates us to have a separate definition for this type of property. And that definition is commutative property. So the addition enjoys the commutative binary property. Means whether you add A to B or B to A, answer is same. So in addition, we generally say add two numbers. We don't say add A to B or B to A. Why? Because addition enjoys the commutative property. And it means that whether you are adding A to B or B to A, their answer is same. So in addition, we generally say add two numbers. We never say add A to B or B to A. But remember, under subtraction, we have to mention what we are subtracting. Under subtraction, we have to mention whether 5 is subtracted to 7 or 7 is subtracted to 5. Because under subtraction, answer will vary. So when you are subtracting any two equations, you have to mention whether we are subtracting A from B or B from A. So dear students, let us see the basic definition of the commutative binary operations. A binary operation star on the set S. If you have a set S and a binary operation star on that set S, it should be first of all a binary operation. Then that binary operation is commutative if A star B is equal to B star A for all AB in S. It should not hold for only one pair. It should hold for each and every pair. So definition से हमें clear होता है कि now addition is a commutative binary operation, but subtraction is not a commutative binary operation. Now, dear students, we already know one more binary operation on the set Z of integers, that is multiplication. Now let us see multiplication is a commutative binary operation or not. If you select similarly any two numbers, say 5, 7, you multiply them, you get 35. Change the order of the elements. It is 5 into 7. And change the order, you write 7 into 5. Settle. The answer is same, 35. Similarly, you select any two numbers, say you select 3, you select 11. 3 into 11 is 33. Change the order. 11 into 3 is still 33. So it means that in general it is true that A into B is equal to B into A for all A, B in Z. So I can write it here as A star B is equal to B star A for all A, B in Z, where star is here multiplication. So multiplication satisfies the commutative property. So we can say that multiplication is also a commutative binary operation on the set Z of integers. So multiplication is commutative binary operation on Z. So till that we have verified that under the three binary operations, addition and multiplication are commutative binary operations, but subtraction is not a commutative binary operation on Z. Dear students, similarly you can verify that addition and multiplication are commutative binary operations on the set Q of rational numbers, on the set R of real numbers, on the set C of complex numbers. But subtraction is not a commutative binary operation on any of the sets Q, C, R. Now the question is, somebody may say, what about division? Actually, division is not a binary operation. Division is not a binary operation on Z. It is not division is not a binary operation on Q set of rational numbers, on R, on C. So if it is not a binary operation, there is no need to check. We cannot check whether it is commutative binary operation. Because word commutative binary is inserted there. So first of all, it should be binary. Then and only then we check whether it is commutative or not. अब कोई पूछे सर अगर हम लेंगे Q star Q minus 0 Q minus 0 means set of non-zero rational numbers. Non-zero rational numbers पे already division एक binary operation है. Then is it commutative or not? You can directly check. If you select any two real irrational numbers 5, 7, you divide them. 5 divided by 7, it is 5 by 7. You take the order, reverse the order. 7 into 5, 7 divided by 5, so it is 7 by 5. Clearly, 5 divided 7 is not equal to 7 divided 5. So it means that division is a binary operation on the set of non-zero rational numbers, but it is not a commutative binary operation. Dear students, now see one more example. If star is a binary operation on the set Q of rational numbers, given by A star B is equal to AB by 2, is star commutative? आपको पहले देखना है what is it a binary operation? अगर मैं आपसे ये भी पूछूं is it a binary operation? It is not usual multiplication. A star B is usual multiplication divided by 2. For all A, B in Q, these are rational numbers. And if you product two rationals, you get a rational. Rational by 2 is also a rational. So AB by 2 is always a rational number for any two rational numbers A and B. So it is a binary operation. Now the next question is we have to discuss, is it commutative? तो इसके लिए हमें सिंपली commutativity की प्रॉपर्टी याद दिलानी है. What is that? A star B should be equal to B star A. So जब भी हमसे पूछा जाएगा, check is it commutative or not, we simply calculate A star B as well as B star A and then check whether they are equal or not. So already it is given A star B is equal to AB by 2. It is given. So let us name this first. Then what is B star A? अब हमें देखना है यहाँ पे ऑपरेशन क्या है. When we operate two elements, it is first element into second element divided by 2. ठीक है. So यहाँ पे first element A नहीं है. Here first element is B. So by this given operation, by first, B star A is first element is B, second element is A divided by 2. Here you get AB by 2, here you get BA by 2. Now the question is, are they equal? See here, in the second equation, it is BA by 2. But in the numerator, it is the usual multiplication. And we have earlier proved that on the set of rational numbers, addition and multiplication are commutative binary operations. So usual multiplication, if it is AB, it is BA. Because ABA is equal to BA. So I can replace this as, this BA can be written as AB divided by 2. Here we can mention that AB is equal to BA. Because multiplication is commutative on Q. So it means that B star A is also equal to AB by 2. Now you can directly verify from first and second. A star B is AB by 2. B star A is AB by 2. From first second we can say that A star B is equal to B star A. It means that the given operation is a commutative binary operation on the set Q of rational numbers. Now see one more example. If another example is given, that star is a binary operation on the set Q of rational numbers and the operation is A star B is equal to A plus 2B. First of all, let us check, is it a binary operation? It is given, but still we try to check. A and B are rational numbers. 2B is a rational number. Twice rational is rational. And then rational plus rational is rational. So this is always a rational number. It means that it is a binary operation. Now we have to check, is it commutative? Wahi basha, we will calculate A star B. It is even given. We will calculate B star A. Then check whether they are equal or not. The question is A star B is given. Let us name this as first. We try to calculate B star A. Now see the operation. What is A star B? A star B is A, means first element. First element is A, so keep first element unchanged, plus 2 times second element. So this is the operation. When you try to use this operation, see that operation. It is first element plus 2 times second element. And what is the first element here? It is not B. Sorry, it is not A, it is B. So it is first element, that is B, plus 2 times second element, twice A. And now see. A star B is A plus 2B. Here B star A is B plus 2A. Now are they equal? They are not equal. You can directly check. It is A plus 2B. It is B plus 2A. Even though we can verify that it is they are equal if and only if A is equal to B. But A and B, it is not necessary that we always take A equal to B. So in particular, समझने के लिए मैं कह रहा हूं, if I take A is equal to 5, B is equal to 3, then calculate A star B. A star B means 5 star 3. So 5 star 3 is first element 5 plus 2 times second element 2 times 3. That is the operation given by here. So that is equal to 6 plus 5, that is 11. So 5 star 3 is 11. Now change the order. That is 3 star 5. Here first element is 3. So it is first element 3 plus 2 times second element 2 times 5. And which implies that 3 star 5 is equal to 10 3, that is 13. Clearly it implies that 3 star 5 is not equal to 5 star 3. Under this binary operation, it means that the result fails here. Commutative property fails here. 3 star 5 is not equal to 5 star 3 implies that the given operation is not commutative. Dear students, now we are going to discuss associative binary operation. इस डेफिनेशन को भी अच्छी तरह समझने के लिए हम पहले कुछ एग्जांपल्स देखते हैं. If we have a binary operation star on the set Z of integers given by A star B is equal to A plus 2B. It is a binary operation. Even you can check. B is integer. Twice integer is integer. Integer plus A integer means sum of two integers is also an integer. So A plus 2B is always an integer for any choice of integers A and B. It means the given operation is a binary operation. Now if I ask you to calculate 4 star 3 under this binary operation given by first, you can easily calculate. First check what is the operation. A star B is first element plus 2 times B second element. So the operation says if you operate A and B, you write first element plus twice second element. Here we are operating 4 and 3. So you write first 4 plus 2 times second element 3. And the answer will be 3 2s are 6 plus 4 plus 6 and it will be 10. It means that 4 star 3 is equal to 10. मेरे कहने का मतलब क्या है? If I give you only two integers, you can operate under the given operation. So if I ask you to calculate this expression and it contains 3 elements, means you have to operate 3 elements by using first. I think your concern should be first, sir. First is a binary operation and it gives us a rule to combine 2 elements only. How can we combine 3 elements in a single go by using first? Yes, it is correct answer. Now the question is, still I am asking you, try to calculate this by using first. Now one of the students may say, sir, if you are forcing us to calculate this by using first, but this can be applied only if for 2 elements. So let us start this. Student first may say, sir, I can say this 4 star 3 star 5. First of all, I can operate 4 and 3. First of all, I can operate 4 and 3. Means 4 and 3, he will operate 4 and 3 by first. And what is 4 star 3? 4 star 3 is 4 plus 2 times 3 star 5. And the answer will be 10 star 5 because 3 2s are 6 4, that is 10 star 5. लेकिन आगे जाने से पहले अगर मैं आपसे ये पूछूं कि एक स्टूडेंट ने इस तरह कैसे किया, he operates from the left side. अब अगर दूसरा स्टूडेंट कहे, सर ये कहां पे लिखा था कि आपको लेफ्ट साइड से ऑपरेट करना है? If I operate from the right side, मीन्स दूसरे स्टूडेंट का अगर कंसर्न है, सर ये 4 star 3 star 5 है. You asked us to calculate. इस स्टूडेंट ने लेफ्ट साइड से कैलकुलेट किया. Let us calculate it on the right side. So स्टूडेंट सेकंड कहेगा, नहीं सर मैं ऐसा करूंगा 3 star 5, I will operate from the right side. इसने ऑपरेट किया पहले 4 और 3 को, but I will operate on the 3 and 5. बिकॉज कहीं पे मेंशन नहीं था कि आपको ऑपरेट करना था लेफ्ट साइड से और राइट साइड से. आई कैन ऑपरेट आइदर फ्रॉम लेफ्ट और फ्रॉम राइट. आगे जाने से पहले अगर मैं आपसे ये पूछूं, आपको क्या लगता है एक्सप्रेशन तो सेम है, यहां पे भी 4 स्टार 3 स्टार 5, यहां पे भी 4 स्टार 3 स्टार 5, बट वेज ऑफ ऑपरेटिंग इज डिफरेंट. ये लेफ्ट साइड से ऑपरेट कर रहा है, वो राइट साइड से ऑपरेट कर रहा है. आपको क्या लगता है कि आंसर सेम आएगा? Probably most of the students may think that yes, answer will be same, but let us check what will be the answer from two different ways. So here it is 10 star 5. Now we can apply first, and what first say? First element plus 2 times second element. So you get 10 plus 2 times 5. So this is equal to 10 plus 10, that is equal to 20. It means that answer of the first student is 20. Now let us see how to solve this when the next student is operating on the right side. So when we operate 3 and 5 first, means 4 remains same, 4 star. What is 3 star 5 by first? So it is first element, that is 3, plus 2 times second element, 2 times 5. So the answer will be 4 star. This is 5 2s are 10 plus 3, that is 13. Now again you get two elements and you have to operate them by using first. So the answer will be first element, that is 4, plus 2 times 13. So you can check that it is 13 to 26 plus 4, that is 30. Now see the difference here. Expression is same, 4 star 3 star 5. Expression is same. This person is operating from the left side, this is operating from the right side, and the different answer comes. Here answer is 20, here answer is 30. So it means that we can conclude that this is not equal to 4 star 3 star 5, because 4 star 3 star 5 is 20 and this is equal to 30. So it means that binary operation दो के लिए apply होता है, but if we have to operate 3 elements, we have to be very cautious. Dear students, now let us see one more example. We know already multiplication is a binary operation on z, set of integer z. Now if I ask you to calculate this same expression 4 star 3 star 5 here. What is star here? Star is multiplication, usual multiplication. So if I ask you to calculate 4 into 3 into 5, are you multiplying 3 numbers in one go? अगर आप multiplication table भी याद दिलाओगे, in multiplication table we have 4 3s are, we have 4 4s are, 4 8s are, but we never see a table which says 4 3s 5s are. Actually we are always operating 2 elements at a time. So the same question arises here. One student may operate from the left side or another student may operate from the right side. So there are 2 ways to operate 3 elements, either from left side make group of 2 or from the right side make group of 2. So if this the first student says, I can calculate, first of all I will multiply 4 and 3. 4 3s are 12, 12 into 5, so it is 60. Now if the second student says, sir, I will operate from the right side first. So 4 is 10, 3 5s are 15, and 15 4s are 16. So it means that in this example, 4 into 3 into 5 is equal to 4 into 3 into 5. So what is the difference between these two types of operations? Both are binary operations on the same set Z. But here, this is not equal to this expression. These two expressions are not equal, but here the two operations are equal. Even though in general you can say that ABC is equal to A into BC for all ABC belongs to Z. So this binary operation multiplication enjoys this property that whether you operate from the left side or you operate from the right side, the answer is same. But this binary operation is not enjoying this property. And this is the property what we are going to discuss, that is the associative binary operation. So what is the basic definition of associative binary operation? A binary operation star on the set S is said to be associative if A star B star C is equal to A star B star C. Means if you have to operate 3 elements, you can operate in 2 ways. If in both the ways answer is same, then we say the operation is associative binary operation. And we can conclude that multiplication is an associative binary operation on Z. Similarly, we can show that addition is an associative binary operation on Z. But we can still prove similarly that subtraction Remember, subtraction is a binary operation on Z, but we can verify that subtraction is not an associative binary operation on Z. You can directly verify that 4 minus 3 minus 5 is not equal to 4 minus 3 minus 5. अब खुद घर में करना है. You can verify this, that this is not equal. Meaning subtraction is also not an associative binary operation on Z. So dear students, we have verified that addition, multiplication, they are associative binary operations on the set Z of integers. Subtraction is not an associative binary operation on the set Z of integers. And one more operation, that is A star B equal to A plus 2B for all A, B in Z. This is also a binary operation on Z, but this is not associative. Now see the importance of associative binary operation. What is its importance? If star is an associative binary operation, see the difference? If star is an associative binary operation, then I ask you to calculate A star B star C. Brackets are not inserted. But if it is associative, it means that whether you operate from the left side or you operate from the right side, answer will be same. Because it is associative. Now, similarly, if I ask you to calculate A star B star C star D star E star F. Now, similarly, if I ask you to calculate this expression and it contains 6 numbers, and if the given operation is associative, there is no ambiguity. Whether you start from left, you operate A with B, or you operate from the right, you operate E with F, or you operate from the middle one, you operate C with D. Answer will always be same. Why same? Because the given operation is associative. So if the given operation is associative, this expression, they are meaningful. There is no ambiguity. But remember, if the given operation star is not associative, what about this expression? We just verified from this binary operation that this expression has 2 different values for the same values of A, B, C. Because if you operate from left, you get one value, and if you operate from right, you get another value. So it means that if the given operation star is not associative, this expression is ambiguous. We are not sure what is the exact value. And similarly, if I say A star B, star C, star D, can you calculate this? Are you sure the answer will be same? No. Because the given operation star is not associative. So if it is not associative, if anybody starts from left, he will get one value, and if anybody starts from right, he will get another value. So this expression is full of ambiguity. So the beauty of associative property is that if it is associative, no need to insert brackets. This expression is meaningful because you will get a unique value. But if it is not associative, this expression is full of ambiguity. So this is the beauty of associative binary operation. So never try to ask a student to calculate A star B star C if the given operation is not associative, because one student may get one answer and another student may get another answer, and they will get confused. Now let us see one more example. If star is a binary operation on Q given by A star B is equal to AB by 2, is star associative? Associativity जब भी हमसे पूछा जाएगा, we have to remember what is the basic definition. So for associativity, we have to check whether this is equal to this. So if associativity is asked, simply we calculate this first, then we calculate this, and check whether the 2 expressions are equal. If they are always equal, then associative, otherwise not. So let us try to calculate here first A star B star C. Basically, we have to operate 3 elements. Associativity में हमें क्या जानना है? If you operate 3 elements in 2 ways, is the answer same or not? Now the question is, if you operate here A star B star C, first of all we operate AB, and what is operation of AB? Product of elements divided by 2. So it is AB by 2 star C. Now see the question here. Now see here, what are the elements now? Here element is AB by 2 and another element is C. Now elements are not A and B. One element is AB by 2, another element is C. And the operation says, if you are operating any 2 elements, you product them, divide them by 2. So the elements are here AB by 2 into C divided by 2. See here, first element into second element divided by 2. And the answer will be ABC divided by 2. So you get A star B star C equal to A, B, C divided by 2. Similarly, if we try to calculate A star, B star, C, if we operate on the right side, A will be same. What will be B star C? B star C is not A, B by 2. Here elements are B and C. And operation says operate them, product them, divided by 2. So it is B into C divided by 2. By the given operation. Now the question is, you have to operate again, but the elements are now A and next element is not B, but next element is BC by 2. Operation says simply multiply them, divide them by 2. So it is A into BC by 2. So this is first element, this is second element, and then divide them by 2. Operation says product of two elements. First element this, second element this, divided by 2. And this is equal to ABC divided by 2. Again, this answer is ABC by 2. This answer is ABC by 2. So it implies that A star B star C is equal to A star B star C. Implies the given operation is associative. Now let us see one more example. If we have the binary operation A star B is equal to A plus 1. What is the operation here? First element plus 1. 1 is not B. First element plus 1. Now we check again here. What is A star B star C? Basically हमें associativity check करनी है. So first of all we will calculate left side this. And what is A star B? Now see the definition. It is A star B is A plus 1. First element plus 1. Now what is first element here? A. So it is A plus 1 star C. Now see that now the elements are not A and B. Now the first element is A plus 1. It is not, they are not three elements. It is one element. A plus 1 is one element and C is second element. So what is the operation? A star B is first element A plus 1. So what is here first element? It is not A, it is A plus 1. So A plus 1 plus 1. See the operation first. Operation is A star B is A plus 1. First element plus 1. And here first element is A plus 1. So A plus 1 first element plus 1. So the answer is overall A plus 2. Now try to calculate next A star B star C. Now if anybody operates from the right side, we will check whether the answer is same or not. See here, A is same because we have to operate first B and C. And in B star C, first element is B, first element is not A. So the operation says first element plus 1. And here first element is B, so it is B plus 1. Is it clear? First element is B, operation says first element plus 1. Now see here, now the first element is A and the second element is B plus 1. Use the operation again. Operation says first element plus 1. So what is first element? A plus 1. See here, this is first element plus 1 and this is deleted completely. B is completely deleted. So here answer is A plus 1, but here answer is A plus 2. So it means that A star B star C is not equal to A star B star C. It means that the given operation is not associative. So it implies A star B star C is not equal to A star B star C. Implies the given operation is not associative. Thanks a lot.